How this presentation came about was I was involved in a project related to anti-money laundering. It ran for 9 months. It included a large structure set of changes as well as the 4 areas I'm going to describe in this presentation. And unusually for us as DBAs, we tend to work on 3 or 4 pieces of work at one time. This was my goal and my only focus for 8 of those 9 months. Why Westpac thinks that a male can actually deal with multiple projects at any one time, I don't really know, but that's what they believe we can do. So the agenda. I'm going to start by talking about SQLJ. Once I've finished with that, I'll move on to looking at how you can transform relational data into XML, use materialized query tables, also look at MQ functionality within triggers, and mention some other features that DB2 have that supports this case of it being evolving past just a pure DBMS. So starting with SQLJ, I'll go over what is it, why use it, how do we get it to work in Westpac, and some other facts and observations. SQLJ itself is a series of steps, therefore you could class it as a process, a method or methodology. You can even class it as a development philosophy. However, it is not a connection type. SQLJ uses JDBC connections. So it's the same as dynamic JDBC connecting through it, type 4. It is not a separate type. Now, if I got 10 cents every time one of my developers told me this, they would have paid for my business class flights here. What you might find when you try and introduce SQLJ, it becomes a battle of philosophies, your DBAs against your developers. From a developer's point of view, they don't necessarily like it. And I'll explain why in the next few slides. From a DBA point of view, it's something we really desire to use. Why we wanted to use it? Twofold. Control. It gave us the ability to actually control the bind parameters. And secondly, it could help us reduce resource usage, especially the fact that we could have static binds instead of dynamic calls. Not having to do short-term prepares a lot of the time, some long-term prepares, we could see actual physical CP2 reductions by doing that. And when you look at how you'll tend to put SQLJ in, you'll put it through a data source, which means you get a generic set of bind parameters attached to that data source. By using SQLJ, you can control it down to the individual package level, which means you can actually have more control over what connection types you're getting through. So how did we implement it? It's a 5-stage process. You have to tag the SQL, and I'll show you how you do that in a minute. You'll need to pre-process it. You'll need to work out how you're going to do your binds. Now, depending on how the politics in your company works, that may or may not be a hard thing, and I'll explain why. You'll need to set up the connections, or you may have to do some connection set work, and then you deploy it. Now, I'm reliably told by my developers this is a standard piece of Java code with SQL inside it. That will cause a dynamic call to the database. If you want to use SQLJ to do the same thing, it would change to this. Now, specifically, you're having to look at the start, you've got that hash sign with SQL. That is you tagging SQL, so that your data source can understand that you're now looking to try and use a SQLJ call and not a normal Java dynamic call. So once you've written the code, you'll have to pre-process it, and you use a command called SQLJ. What it does is create a .java file, and this is what will be deployed. It will create potentially one to many other files, and you will need them as part of an additional process. But your main Java file, which is what you would do a Java app, is what's created from this. You then use the second command, DB2 SQL J Customize, and it will create serialized files, which in effect are like the DBRMs. And you'll get one per isolation level. Then you can get the fun part. Now, I've worked with mainframes for 20 years. My boss has worked for mainframes for probably another 10 years on top of that. We're control freaks. We don't like applications automatically binding stuff because we don't control what the bind parameters are. So we have to look at ways of doing this manually, but you can have the process working automatically, and it can come out the same command, the DB2 SQL J Customize. Takes some little setup because you'll have to make sure that the user that's doing it has the authority to be able to do binds. You'll have to connect it, and you'll have to make sure where is it being run from. You can run it, you're running it off the mainframe, or in all likelihood, or you could be running it inside Unix system services on the mainframe, but you're not attached to the subsystem itself. You're going to have to attach to the subsystem to get the bind to then work. You can do it manually by command, DB2 SQL J bind, but again, that's running off the mainframe. So you'll have to have Unix, Linux, Windows skills to be able to do this. Or you can transfer the DBRMs themselves and get them onto the mainframe and use a normal bind processing. So running a DB2 command job which has got bind parameters. That's where we eventually managed to head for after some discussions, shall we say. Connecting the packages to the actual system itself will usually be done automatically, and it's in the serialized profiles that you've created with the SQLJ Customize command. It can also be defined in the data source. Now in this case we were using WebSphere, so there are certain parameters within the WebSphere setup that you put in what the data source is to tell them where you're picking up the packages from. Another alternative to this, and it gives you slightly more control, is you can bind them into a plan and then use the plan name parameter within your data source setup to tell it which plan you want to execute. From our point of view, as I said, we saw CPU reductions. We got about 8% reduction in the CPU, and that's because we saved a lot of prepare times. Partly that was because they weren't doing proper parameter definitions with param markers, and we were getting long prepares instead of shorts. The other thing is we did have to negotiate with the developers. As I said, they don't like this. Why? Java developer writes his SQL code, does a deploy, gets a .java file, he's happy. Now he's got to go through a two or three stage process. So from an agile development point of view, they don't like this, it's extra time. But it then becomes a case of how much time are you going to save there against how much time are you going to actually do running this application and burning your CPU and potentially burning extra elapsed time. Again, binds we had to negotiate for, but as a degree of difficulty point of view, once they got used to it, the developers didn't find it that laborious. It's the initial setup you have to get over. Once it's set up, once they've got into the process, it's fine. But I'd suggest using tooling. The more manual process you put in this, the longer it takes, the more kickback you get against it. As part of the Java or the SQL code that was developed within this Java, we decided to actually transform relational database directly to XML. So again, what I'll do with this is go through what is this, why is it, how to use it, etc. XML transformation is a process or technique that utilize XML functionality and CTEs to take relational data and actually return an XML string. So we used it for the following 5 reasons. 1, it can improve understandability. From a professional aspect, you think about it now, XML is not that young a language. Lots of college people have been taught it, and lots of developers like to use it. If you also go into the architect area, that it's becoming something that they want to use for standard transformation between applications. It is a pseudo, or it's classed as a pseudo data communication standard. From a point of view, we are, as a bank, companies like Visa and MasterCard are now dictating to Westpac that we have to send them XML. In terms of some of our transformation processes and some of our card processing. It allowed us to get asset reuse. By that I mean we didn't have to go and completely redesign our database and redesign our data and make it XML. All we did was take the data that was already there and then transform it for reuse. So by that, it was made it easier for us to do things instead of having to create a whole new database and set of database tables that were supporting purely XML stuff, especially as some of this data was already embedded quite deeply into our CRM. XML is a pretty flexible language. If you think about when you're dealing with relational data, you've got a kind of fixed format. If you want something new, you've got to add it, you add it to a file length, you change the file length, etc. XML is nodes. If you add a node, if the person doesn't really want to use it, they won't pick it up. If you remove the node, that's where you can have slight impact details, but it's easy to remove the node, or you can actually blank the node. So XML itself is a pretty flexible data format. And actually we found some performance improvements by doing this. So when do you want to use it? Really when you've got data that is hierarchical in its nature. So organization charts, family trees are a couple of examples. If you think about a data model design, you're looking at something like a snowflake or potentially a star schema. So it may become useful in sort of analytical warehouse situations, but also in some OLTP situations. If you've got a flat pyramid structure where you've got one parent and many, many children, and you have to join across all those children, XML might be an ideal format to use. To use the XML transformation, we also need to use common table expressions. Now, what are these? They're dynamic tables or views created from a result set that you've defined in your SQL. They're different from a result set in a subquery. Now, the reason that is a subquery, you can only use it when it's attached to your piece of SQL itself. So if you're using a subquery in an in list, it only affects the in list. Common table expression you actually define before you define your first piece of SQL, and then that is usable from the moment you've defined it to any other piece of SQL you then write onwards. One thing that differs between ZOS and LUW though is a common table expression, at least up to version 10, cannot be defined within itself. Now you can in LUW 10.1. So there is no self-referencing of a common table expression as yet. Why do we use them? You get SQL simplification in certain cases, and they can provide performance benefits. So how would you transform relational data to XML? So here's an example, and the colors do have some meaning. Your normal white bits are normal SQL statements. Your yellow are the actual XML functions you could use. Red bits are basically common table expressions, and the black bit is the last smart little bit that you want to really understand. Here we've used 3 different functions: XML element, XML forest, and XML aggregate. An XML element creates an XML element. It creates an individual node. You must have at least one of these in an XML. And you must embed it that is the top level. You want to have a root element in XML, because if you don't have XML. you'll get a string. And trust me, if you use some tools, you'll see it pretty quickly that it is a string and not XML, because it won't come up as an XML format. Now you can use XML element and embed XML elements within them time and time again to create your structure. However, if you're going for something at the same level, you might want to use XML forest, because that allows you to create multiple XML elements at the same time in one statement. Then what you can do is you can create pieces of XML and you can aggregate them together using the XML aggregate function. And the last little piece is, once you've created all this, if you do it back to systummy1 and use another XML aggregate, you can actually take something down and create a single row result set for your XML document. Now, in one case, we took something that if we had relationally joined it, would have given us 54,000 jumps to the database and got it down to 2. One was a SQL statement, the other was a commit statement. And that is what that query on the previous page was create if you were using off the sample database that you can get on ZOS. So you can see the top level is you've got employee details, that's your root element, and then it's created 2 name elements, and with inside that you've got the other stuff as it comes down. So if I go back to that, what you actually get is you get the name element from that first common table expression, which is project1.employee now. You get the project number, the start date and the end date, forested, and then you're joining that to a second common table expression, which is giving you first name, last name, and then you're joining it to the last one to get the employee details and aggregating it again, and that's giving you that whole set of XML. So there you've got 2 employees, one with 3 projects and one with 1, returned in a single row. So that's a single row result set. It's just shown in XML format. So by using this process, we saw reduction in CPU, we saw reduction in elapsed time, and as I mentioned, we saw significant reductions in our calls to the database. In this example, 4,600 calls to the database down to 2. In this case, we took 12 cursors and a simpleton select and rewrote it to one XML statement, and it returned a single row result set, and then there was a commit. Then one of my colleagues had a Slate Epiphany, and we actually managed to reduce the elapsed time by 98%. And we did this by realizing that what we were doing was we were constantly translating this stuff back to XML, and there was really no need for it. So now we translated it once, stored it as XML into the database in an XML column, and then let the process read the XML back. And the reason this worked was it was going back to our service bus, and the service bus standard communication format was what? Anybody like to take a guess? XML. So we were doing the transformation once instead of letting them get it back in relational and having to translate it for us. Some other useful XML functions. There's XML attribute. You can add an attribute to an XML node. I still don't quite get why people want to do that, but they do. XML concat is another way to concatenate XML together. But I will warn you, be careful of this. If you concatenate 2 XML string or 2 XML documents together and you don't put an overarching root node, you lose your XML. If you end up with 2 root nodes on an XML document, you no longer have XML. You have a string. XML is a hierarchy that has a single point of control. It has one and only root node. So if you take one thing away from this afternoon, please remember that. Otherwise you find your XML does not work. And you sit there scratching your head for 2 hours going, what the hell have I done? And in my case, that's not a good look because I end up with red marks. For those of you who do system administration, you need to know about a couple of Z-terms, because likely when you start up, you probably blow through them and you will be reading manuals as to why you've done this. One is XML value. That's a setting of how much XML storage a single user can get. And if you don't write your SQL properly, because you're using CTEs to try and get to this single row result set, you can actually easily blow this. Because what happens if you create at the very top 100 million row result set that you've created XML for, you're chewing up the storage in XML. So the same principles of normal SQL development apply. Filter as far up the chain as you can, and filter as much out in your result sets as you go through. Otherwise, you probably will have your sysprog going, you don't have enough storage to do what you want to do. Your second one is XML val-s, and that is a system-wide setting. And trust me, you do not want to get this wrong, as Paul did. I followed the guidelines in the manual and set this to 10 gig without actually validating that my system underneath had real storage. This needs the real storage underneath to support it, because otherwise you can crash your LPAR. Now fortunately I didn't do it in production, but I did do it in a performance test environment, and I had a senior manager sitting behind my desk asking me what was going on. It was not a pleasant feeling, considering they crashed the LPAR 6 times in 3 days. So for those who are system administrators, make sure you've got that setting and make sure you've got the underlying real memory to support it. Another technique we then used over the top of the XML was actually use some materialized query tables to help us with performance as well. So again, quickly go over what are they, why we use them, how to define one, and some other observations. MQT stands for Materialized Query Table. Similar to a common table expression, but not exactly the same. Gain gets the result set of a query, but this is a physicalization of that result set into a table. It's almost taking a create table and a create view and join them into set one statement, and that's what you're getting. You're creating a table with columns, but you're getting your data from a query to get your result set back. It can be system or user maintained. You can defer the population. So it can either be populated at create time, or you can defer the population until a time you desire. It can also support indexes, which means it can help with performance. However, one limitation, certainly up to DB2 version 10, is that you cannot define a materialized query table in a foreign key relationship, much as Paul would like to. Why did we use them? Again, performance and also simplification. You can write quite complex SQL, create a result set, and actually hide the complexity from your developers and let them use a much more simplistic access method to get to the data. So you can give this to people who really truly understand SQL development, can tune it, let them do that, create the table, and then you can give it to less experienced developers to get access to the data. So that's a sample create materialized query table. As you can see in the white, for those of you who are DBAs, that looks pretty much similar to concepts you would do in a create table. The yellow stuff is the additional stuff on materialization, and that first and second lines are similar to how you would create a view. That's a physical example within Westpac. So here we've created a table and we've used summarization. And then you just access it as you would a normal table. Select whatever column you want, put in host variables from the object, and use your standard SQL predicates. In essence, it really is just like a table or a view that you're accessing. Now, sometimes what a materialized query table can allow is automatic query rewrite behind the scenes. Now, fortunately, I could never get an example of this to work in Westpac, but it's done by the optimizer. So the optimizer may choose this path. And what you'll see is an access type M in the plan table telling you you've got a materialized query table use, and you'll see the actual materialized query table object name. Again, as I said, performance improvements. We saw between 17 and 28% savings by using materialization in query tables. And the reason for this is, and I'll show you in an appendix an example, is because we're repeatedly accessing the same style of table or the same data multiple times in the query. So they're rerunning the same query and materializing it effectively 5 or 6 times, where we did it once by doing this. And in another example, we took something that was running for hundreds of seconds down to seconds. It saved us hundreds of thousands of dollars. A couple of limitations. You can't use all SQL statements. For example, I tried to use XML creation to create a materialized query table, and you can't do that. So you can't go use XML element, forest, aggregate, and create a complex XML creation and make it a materialized query table. Now, it may have been just how I was writing the code, but I kept getting an error telling me that it did not like it. And there are lots of limitations. There are at least 15 in the manuals in version 10. So you probably want to try and read them and make sure you do understand them, because it will not allow you to do certain things. But they are really powerful, and they can be extremely useful. Now, after having done all this, and we thought we were finished with the project, our architects come along and told us we'd found a little problem. We'd managed to break a process. So part of the AML legislation in New Zealand means that we have to cite people's documentation. Now, before that, we had automated account opening processes in our internet banking, and you could now open an account. The problem was those two things didn't match anymore. And as a result of that, we actually broke the automation process, and we had to find a way of getting it to work. Now, how we did this was put a quick and dirty fix in, and we used MQ series functionality. So what we did was put a trigger that used an MQ Send function to actually trigger off data being changed to allow us to then switch some other data and call by calling the service underneath. So again, quickly go through some what is MQ, why, when, how to use MQ Send. MQ is a supplied set of APIs, and they're invoked by a set of built-in functions, similar to user-defined functions. As of version 10, there are 9. There were more in version 9 that's actually reduced. So you've got several reads, several receives, and an MQ send. MQ reads, read queues, MQ receive, pull stuff off queues, MQ send writes to a queue. As I say, reasons we used it: consistency, integrity. It allowed us to keep our data integrity because we had actually broken the way the things had worked because of the way that applications have been designed. The other reason you might want to use this truly allows DB2 to function in a service-oriented architecture. You can now trigger service requests over data changes. So by putting triggers on updates, deletes, inserts. So how do you do this? Well, you'll need to understand what you want to write to your MQ queue. You'll need to define a service. You may optionally want to define a service policy. You'll need to configure the MQ Send function, and then you'll need to define this inside a trigger. I'll take you through how to do that. So the input details for defining a service, and it's the MQ service table, the catalog table that you use. You need a service name. You'll need to tell it the queue manager, actual queue name you want to use. Optionally, you'll need to put a coded character set and an encoding ID, and you probably want to put a service description on it to let you know what service you're actually using. You can also optionally define a service policy, which then is a policy you can attach to these services, which allows it to give it some other information. You do need a policy name, a send priority, a whole bunch of things there that relate to dealing with MQ itself. I'm not an MQ expert, so I don't quite understand all of these, and I didn't have to use all of these. But things like, do you want to make the message persistent or not? You set here. Do you want a retry count, etc.? You set in here. And you can attach the policy to the service that you send. So for an MQ send, you will need a service, you will need the message data. The other two are optional. So if you put the send inside the trigger, create the trigger, and then it simply select DB2 MQ send service, policy, or send service name, policy, the MQ message detail, and a correlation ID if you need one. And you can use, when you're actually creating the MQ message itself, you can go and get your data from columns on database tables that you've got access to. So you don't have to have the whole string. You may have to string some pieces in, but if the data, and if you're lucky, all your data is sitting in DB2 tables, it's simply selecting those columns from the tables you need the data from to create the message. And that's an example of how we did it within Westpac. So there's a trigger after update of a column on a table, when conditions as to when this goes, and then send the message. Now most of that you can see is text, but there is concatenations of actual fields on the database. And this works pretty much 99.9% of the time. It does occasionally break. The reasons why it might break is you've done an upgrade and you've actually found you've swapped things, and then setup is not quite as you expect. So the MQ APIs need to run in a workload managed environment. So you will have to talk to probably your MVS or System Z sysprogs to get them to set up WM environments and possibly WM policies to allow these functions to run. Now, where that is defined in the actual MQ functions themselves that are within the catalog, and you can change them if you have access. You will also need to make sure that the users that are running, or the user that will be executing the MQ function, has security to be able to write to the MQ queue and access the MQ service. And as this is a development of code, you probably do want to put this through a normal, solid development lifecycle. In this case, as I said, this was a quick and dirty solution. Not the prettiest thing to do. It's a fire and forget process. And we had to build another process behind it to clean up on the few occasions it does break. But as I say, it works 99.9% of the time, so it does what it needs to really do. Some other capabilities in DB2 that I really didn't get to play with I would have liked. Recursive SQL, the ability to actually get SQL to recursively build stuff and loop within a SQL statement without having to write in a prop, without having to actually put in a program. Temporal capabilities we haven't used in that project, we have had to use recently because of limitations with XML. The ability to time travel on the same table. Store procedures, user-defined functions have been there for some time. DB2 Analytics Accelerator, the ability to offload stuff. JSON capabilities coming in with DB2 11, and integration with Hadoop and via Big Insights. There's all these other functionality and capabilities within inside DB2, which makes it far more than just tables, views, and indexes. So in conclusion, I would say DB2 is far more than tables, views, and indexes. Hopefully the last 45 minutes I've helped to demonstrate that. DB2 is not just a database anymore. It is functionality. It can be a service provider. It can be a service requester. It deals with XML. It deals with JSON. It deals with relational data. It integrates with Hadoop via Big Insights. It has the Analytics Accelerator, which is based on the teaser technology. And so from that point of view, I'd also argue it's no longer a relational database management system. And given it can do all this service-orientated architecture, be a service requester and service provider, I'd actually argue past it being just a DBMS and call it a fully functioning data service software. And since you've been really quiet, now's your chance to speak up. So does anybody have any questions? Yes, sir.
You mentioned when you were talking about XML that you guys were able to convert a particular workload from over 4,000 queries to 2. I was curious, how do you guys recognize that you had an application that was basically querying DB2 to build an XML document and I guess leverage XML functionality that way?
So I'll try and summarize your question for everybody first. Effectively, you would like to know how did we recognize the opportunity to use XML in this particular case that got us down from 4,600 calls to 2. That really came down to me seeing a piece of code and thinking, why the hell was it done this way? Initially, I looked at it and was saying, why were we going back and calling a service 20 times a day to go and get our product data, which was referential type data, and it just seemed a stupid thing to do. And then I had a look at the code, and the code was written in such a way that it was effectively going to each table separately via cursors. So it had 12 cursors, one master, a living child, and a singleton select. And Paul looked at it and went, why is this not joined? Then wrote it as a join, and my jaw dropped when it went up to 55,000 database calls. And that's when you get this effect of a very flat pyramid, one parent, many children. You start to Cartesian your product, because what happens is your first join gets a result set. Your second join is joining back to that result set. It's not joining to the master table anymore. So if you do 2 by 2 by 2 by 2, you suddenly see how it exponentially grows. And when we run the join construct compared to the actual original, our CPU trebled. So then there must be a better way to do this. And don't ask me how I came to XML, but for some weird reason I did. So it was really just Curious George syndrome, in effect. But what I've learned is from that is to look for certain designs and certain patterns in the data, and that's why I'm saying things like family trees, organizational structures, star schemas, snowflake designs. Anything that looks like a hierarchy, you may want to consider XML, because XML is a hierarchical data storage system. Relational data is not the same as that. It's different. It's an entity to entity relationship. and it's extremely good at what it does, but it's not always the best thing to use. Hopefully that answers your question. Any other questions? In that case, ladies and gentlemen, thank you very much for your time.